One. What's up, everyone? Welcome to Simulation. We are on episode 99 with Anting Shen.
Hi.
Thanks for coming on the show.
Yeah, thanks, Alan.
Yes, I'm excited. Anting and I go back to, what was it, your freshman year, my sophomore year of high school?
Something like that, yeah.
Something like that. So it's been like, how long is that? 8 years, right?
I don't remember.
No, is it
9?
9 years?
9?
10 years?
Yeah, something like that, yeah.
Oh my goodness. Yeah, because that was 15, I'm 25, 10 years, yeah. Yeah. Holy cow. So that's when we first met, and we were doing a bunch of funny high school-y shit then.
Like debate? No, you
like debate and Teenage Republicans Club, which
Club.
Now Anting and I find ourselves much more independent free thinkers. Is that fair to say?
I think so. Although people here still think I'm conservative, people in like South Dakota think I'm liberal, so.
I'm so happy that you made it out to the Bay. You went to Berkeley. You did a master's in computer science and electrical engineering.
Yep.
And then you pursued work in perception systems for autonomous vehicles at DeepScale.
Yeah, it's actually started by people in my lab at Berkeley. So my professor and one of his PhD students, Forrest, Ian Dola, they started it. So.
Yeah, I noticed that Kurt, who's the advisor of the lab, he's now an advisor of the company, right?
Yeah, he's a co-founder.
He's a co-founder of the company. Right. Cool. Yeah. So then the work, did it come out of the robot learning or the Aspire lab, or which one?
Out of the Aspire lab. We were doing a lot of like small neural networks, like compacting them down. One of our famous papers is called SqueezeNet, where we took AlexNet, which is like one of these popular neural networks for image classification, and we reduced the number of parameters by like 500x. So what used to be like hundreds of megabytes, it became half a megabyte. So now we're leveraging that technology of squeezing neural networks to deploy deep learning in autonomous vehicles.
Okay. Yeah. So when the vehicle is perceiving its environment, it's taking a lot of data, you figured out how to squeeze that data down to lower amounts.
No, so there's neural networks that process all this data. Mm-hmm. And usually neural networks are very computationally expensive, and they require like big NVIDIA GPUs. Mm-hmm. And cars don't have those, or most cars don't have those. So we're trying to figure out how to get those computer vision algorithms to run on small in-car processors.
Awesome. Okay, so then the external environment being processed through computer vision on a smaller processor via the neural networks on a smaller computer processor. Right. So you guys were figuring out at the Spire Lab how to crunch it down.
Right.
Okay, and then that seemed to be successful, and then that was like, aha, this would work for autonomous vehicles.
Yeah. Although there's like lots of different computer vision neural network architectures, so we squeezed one neural network that was for image classification, tells you like, is this image a cat or a dog, for example. But for driving situations, there's a lot more other algorithms like object detection or like semantic segmentation, which is like figuring out exactly the outlines of each vehicle or detecting the depth, and all those algorithms, they each usually have their own neural networks, and we apply the same principles to squeeze them down.
So they all have their own neural network. So depth has its own neural network, and so does the outline of the object?
Normally in like academia, people like write a neural network for a specific problem. But obviously if you're deploying in a car and you have all these neural networks, you want to like somehow combine them and have them share computation. So then it doesn't use as much compute as just having 5 different neural networks. Yeah.
Okay, so it does then use separate neural networks for depth or for the outside of the vehicle or for.
Well, we combine them into a single one.
You combine them into a single one. Huh. Okay.
Yeah.
So normally for classification it would be just a single object, but because you're doing it in a computer vision trying to analyze the whole environment, then you bring in all the different variables into one.
Right. There's just a lot of different computer vision tasks that need to be done.
Yeah. Damn, okay, so what does the Aspire Lab normally work on?
So the Aspire Lab has a history of parallel computing, and just computational efficiency.
Cool.
So I joke that the lab usually just takes whatever is popular now and makes it way faster. So when I was at the lab, the popular thing was like AI and neural networks.
Yeah.
So
it still is, isn't it?
I think it still is a popular
maybe blockchain or quantum computing is now there.
Maybe Aspire Lab, I think, got renamed to like the Rise Lab, which has something else that I don't remember. Something with security, but probably a lot of AI still. So.
Okay, so then as you figure out this process and you begin to apply it to autonomous vehicles, this has been about 2 years or 2.5 years? How long has DeepScale been around now?
Yeah, well, Forrest and Kurt, they started working on DeepScale probably in like 2015-ish, or maybe even earlier than that. But obviously, with all startups, you do a lot of customer exploration.
Yep.
And then you find the application, so it has changed over time. So I don't think there's like a solid start date. When we first got funding was probably like 2016.
And that's when they were able to bring you on board and other people on board. Okay, so, all right, I want to take this a couple ways. I wonder if we should let's start with some of the technical stuff, and then I want to get to some of the vision stuff, because you're already the visionary stuff, because you're already in pilots with OEMs, right?
Yeah.
Yeah. Which is really exciting, because then you're actually putting your software to the test.
Right.
Yeah. But you're not designing any hardware. You're not manufacturing.
We're not building any hardware.
You're using existing hardware.
Yep.
Okay, so now let's go through that. What is the existing hardware that you're using?
So hardware for neural networks, usually people use NVIDIA GPUs.
Yep.
NVIDIA has tried making smaller GPUs, like their like TX ones, those smaller GPUs, and they have like a Drive PX platform that's specifically designed for autonomous driving scenarios, and I think they're in a couple of Tesla cars. But those GPUs are still really big and power hungry and pretty expensive. So we worked with a lot even smaller GPUs than that, like ARM CPUs with accelerators, for example. So it would be stuff like TI's TDA2X or some Renesas or NXP processors.
And who makes that?
Yeah, those companies like TI, NXP, and Renesas.
Those are the company names.
Yeah, you don't hear about them because they make like autonomous chips, but like NVIDIA has like 1% of the processor market in cars. And these are like the big players.
TI, NDX,
NXP. Yeah.
Huh.
These semiconductor companies merge all the time, so sometimes it's easy to get their names confused, but yeah.
Okay, TI is in Texas Instruments?
Yep.
Ah.
Yeah.
Interesting.
Yep.
Last time I remember hearing about them was the calculator days.
Yep.
Oh, great. So they actually make processors.
Yeah, they make processors.
Interesting. Yeah. For autonomous vehicles.
Yeah, or just for vehicles in general. Your car probably has processors from these companies.
And so now okay, so let's go through a couple things here. So the first is that the processor that they're now putting into the vehicle, we're trying to make sure that it's not going to be sucking a lot of the power from the car to perceive the environment and to make the analysis.
Right. You'll usually, I think, mostly comes down to cost. Power is an issue when you get to because cooling 200 watts is kind of annoying. Yeah. But mostly it's for cost reasons, and also these processors are already automotive grade and they've been certified. These guys have been in the automotive industry for decades.
So rather than maybe paying an extra $10,000 for your car to be autonomous, you might want to bring that cost down to only $2,000 or $3,000 more for it to be autonomous.
So, yeah, I would say so.
So like that.
Well, so this is one side of what DeepScale works on, and it's lowering cost, but then we're also building technology that enables the L4, L5 cars where you might not care about cost as much.
What's L4, L5 car?
So there's 5 levels of autonomous driving.
I remember learning about this a little bit ago.
Yeah.
Okay. So give a refresher. Yeah.
Sure. The way I like to think of it is So like L2 is where you can take your feet off. So this is like adaptive cruise control, for example, like whereas L1 is just regular cruise control, and then L3 is you can take your hands off the steering wheel, and it does lane keeping and so on, but you still have to pay attention to the car.
Yep.
And L4 I think of as you can take your eyes off the road, where you don't have to pay attention, and if the car's like, I'm about to enter an area that I don't know how to drive, please take over, then you start paying attention. So right now, for example, Tesla's technology is at like L3 or so, because you have beeps at you and immediately have to take over and have to constantly pay attention.
Yes.
And then L5 I think of as you just turn your brain off and it just...
Exactly, sleep.
Yeah. Exactly.
Huh, that's good. I like the... Okay, so you said you guys were also working on L4, L5 technology.
Right.
Okay.
So we work on some L4, L5 technology, but then we can also take that technology, squeeze it down, bring it to the L2, L3 market.
Okay.
Yeah.
Okay, so in the process of working on L4, L5 technology, what does that look like at DeepScale?
What do you mean by that?
So, like, what would it look like for you to make the software that's needed for the human to be able to be on their phone or on a magazine or whatever, whoever uses magazines, but to be doing whatever they want in the car, and then to get a notification from the car, hey, can you pay attention now? I'm about to go through this area, or to even be sleeping. Yes. How do you build out that system?
So we only build a very small portion of that system. So usually for these L4, L5 systems, there's sensing, and there's perception, there's like high definition maps that know exactly where all the lanes are in every street and know where your car is, and controls to actually figure out how the car should behave, and then there's like actuation that actually moves the car. So we only work on perception, so taking the data from sensors, understanding that environment, but we don't make the decisions on what to do.
Okay, yeah. So then the sensors themselves have their limits, and there's other people working on the sensors and making the sensors better. You take the best sensors and you have your software use the sensor technology to take in the data, then you crunch the data in efficient ways, process it, and then that's what DeepScale does, and then it sends that signal to the actuators that actually make the movements.
Yeah, it sends it to a control system that has to make these decisions. That's like, we say, there's a car in front of you, the control system has to figure out, do I wait behind this car, do I go around them, for example.
Okay, so now let's do some of the more, so let's recap one more time. Is you're both working on decreasing the cost on the hardware side of things with the hardware players to bring it down to hopefully a couple $1,000 per car or so.
We're trying to enable better L2, L3 features for way less than thousands of dollars.
Exactly. Yeah.
For example, right now a lot of cars have like emergency braking.
Yeah.
But a lot of them do it based on a radar. It's like radar in front of the car, it sees a car, and then it brakes. But radar doesn't really work on pedestrians, for example. So you really need to have a radar and a camera so that you can see the pedestrian coming out. So these systems, right now I feel like people kind of just like check, like emergency braking done, but they should definitely be improved a lot.
Because it doesn't work for humans unless there's a camera.
Right.
Radar won't work for. Now quick. So that's one side. The other side is working on the L4, L5 technology side of things. Right. Okay. Now on the sensing technology that you're using, what is the sensing technology that you're using? Can we list all the different ones? Because there's too many in the first place. There's like radar, LiDAR. Then there's camera. What else?
And maybe ultrasound.
Ultrasound. Okay, so
that's your car's parking sensor that like beeps at you. That's ultrasound.
Oh, it's sending a little sound. It's a sound wave. Is that what it is?
Yeah, I think so.
And then it's reflecting back.
I don't know if you ever played with them in like high school. There's like a little distance sensor you connect to TI calculators. And
yeah.
Yeah, it's like those things in your car.
That's right. And there's an ultrasound on a lot of the first robotics robots for the kids as well.
Yeah, those things. So they're in
Lego
your
League
cars
ones.
too.
Yeah. Okay. So radar uses infrared.
it uses like radar.
Radar, so it uses radar wave, which is the microwave?
I forget what frequency it's in.
Okay, but it's below the visible light spectrum, right? It's longer wave, right?
I think
radar?
So, yeah.
I think it is too.
It is definitely longer wave. Yep.
And then LiDAR is light radar.
Yeah.
So it's using light pulses, and then it's reflecting back and capturing it,
yep.
right? Okay, so, and that's the ones that spin uncontrollably on top of the cars.
Those are the LiDARs, yeah.
Okay, so there's...
They also have LiDARs that don't spin, but...
LiDARs that don't spin, because then they just stay and shoot and shoot and shoot and shoot, but they don't...
Yeah, sometimes they have like micro mirrors, and then it uses those mirrors to scan.
Okay.
Yeah.
Okay. So then as let's say as it's spinning and as it shoots the light, it reflects off of the surface. It comes back and then it senses the depth of that.
How
object.
long it took the light to come back.
How long
and then it measures that time.
And then it has to do that for every single couple centimeters, basically, or a couple inches, or however far. And that's a lot of sensing that it's got to do, and then a lot of processing. Mm-hmm. Okay. So then,
usually I think it's like maybe fires 20,000 times a second.
20,000 a second.
Yeah.
Wow. Okay, and then there's camera.
Yep.
Now, do you guys work with camera?
Yes, that's probably our main one.
Okay.
Yeah.
Okay. So, all right. So now, 15 minute. All right, 15-minute timer. Let's go power rounds. Thank you, Ron. All right. So, okay. Now let's do this. So, camera. We're currently looking at cameras. We're using cameras.
Yep.
Let's say we're using our smartphone camera. We're pointing right now. Let's say the camera's being pointed at us. Okay, the camera's being pointed at us with the camera. Let's say the middle camera.
Yep.
As it's doing that, does your software recognize where we are at? How far away we are? Mm-hmm. Yeah.
Yeah. So this is object detection, which is deep learning based. So a neural network takes the image as input and then outputs the locations of each object that you want to recognize.
How does it get the depth sensing?
So depth sensing, there's a bunch of different ways to do it. So one way, there's like traditional computer vision algorithms that take two cameras and then do like stereo matching to find the depth. There's another way where you detect the person or car and then use some other sensor to get the depth. Or the third way is just like you learn it through the neural network. For example, if you cover up one of your eyes, you can still tell how far away things are. Mm-hmm. And the neural network's able to learn that as well.
Okay, so because I know that it's really tough, first of all, to make the understanding of neural networks relatable in lay terms. It's tough.
That's true.
I'm gonna try and have Forrest back on the show, or you on the show, in the next couple of months, hopefully when you guys are visiting and stuff, SF, and we'll try and unpack a very simple way to understand neural networks.
Yeah, that'd be great. I think, I've seen a couple of pretty good explanations that everyone can understand. So.
Good. Okay, so we'll do that. But for the end of this show, what we'll do is we'll talk about the current. Let's go back to this. So we had L0 to L5. Tesla's currently around L2 to L3. Yep. Can you speak on who's using DeepScale?
I think right now we're focusing on L2, L3. In terms of who's using DeepScale,
and then the companies.
L4, L5 is just quite a ways down the road. So.
Can you tell us which companies, or not yet?
So one partnership we announced was with Hella Aglaia.
Hella?
They're actually called Hella. So there's a lot of jokes.
Are they in California?
They're in Germany.
They're in Germany.
Yeah.
Cool.
So I think Hella's like a family name or something.
Yeah.
But now we just make.
Jokes about it,
Jokes about it, yeah.
So they're using your software now in German technology.
Yeah, so we made a partnership with them to develop this technology because they're a tier 1 supplier. They supply to OEMs. So.
Okay, they supply to OEMs.
Yeah. Okay.
So then their OEMs will purchase from Hella, who is now purchasing your software to add to their sensor systems.
Yeah.
Okay, now. I'm sure that this is talked about a lot. What are your thoughts about the trolley problem?
Yes. So
and just to clarify here, you have the chance of either the autonomous vehicle will either hit one person and injure one person, or swerve to the side and injure 5 people. How does one program make these decisions?
So no one programs solutions to the trolley problem because they're far from smart enough to understand it. This is like not a thing people programming self-driving cars worry about. Like they program, if you see person, don't hit person. And then if you see person, don't hit person. So like.
And then if other option is hit 5 people, then what?
It doesn't evaluate like option. It's just like these algorithms are too dumb to understand ethics or morality, and it's not a thing that people think about, I think.
For now.
Yeah, for now.
Okay, what are your thoughts about the displacement of about, there's 3 million or so drivers in the US, truck, car, taxi, but there's also plenty of jobs. For example, DeepScale now has a team of 20 people, 12 people, something like that.
20-ish, yeah.
20-ish. So you've hired, there's 20 new jobs, right? Mm-hmm. So there are new jobs coming in as there are jobs taken away. Yep. So what are your thoughts about what's going to happen with that, and also how to retrain, etc.?
Yeah, I don't think I think about the jobs as much, since right now we're mostly focused on making cars less crashable and increasing the safety. We're working on like L2, L3 systems that just like save lives, and they're not really displacing jobs right now. So that's not something that we're actively worrying about at the moment.
Yeah.
But in the future, I think it would be like anything else in the past that has display jobs, all the automation in any other sectors that we've seen. I think people will probably switch over to more services-oriented jobs, but that's just my guess. I don't think I have thought about it enough.
And like you said, you're focused on saving lives in this L2, L3 category right now, that the person is maybe losing their focus from the vehicle. The vehicle is actually more focused on the road and perceiving its environment than even the human is. Yeah. There's so many instances of humans. What is it? 1.25 million accidents or deaths per year across the world.
Something like that.
Yeah, wow, that's so many. Yeah, if perception systems for autonomous vehicles can help us decrease that amount of deaths, that's fantastic. Yep. Okay, how about we ask you, what are your thoughts about the autonomous vehicle economy that's kind of going to start happening, where I purchase an autonomous vehicle for whatever, $40,000, and then I just let it go and make me money, and as a decentralized entity that goes and makes money.
Yeah. So we'll definitely see this is pretty far down the road, I think. So
like 10 years, hopefully.
In like maybe 10 years. We'll definitely see a lot of autonomous taxi fleets, and I think people will still want to own cars. There will still be people that want to own cars, but a lot fewer. And I think what you said, you can rent out your self-driving car for other people to use. So I see that happening,
How about, what are your thoughts, because we touched a little bit on the ethics of like the trolley problem. You're like, we're nowhere near that. It's so dumb. It's just trying to recognize one person and avoid one person.
It sees a person and it hits like some line in the code that says, if see person, apply brakes. And then it does that.
Yeah. Okay, so that's that. Now, what about do you have, let's go 10 years down the line again, okay? So I'm getting into an autonomous vehicle. Let's say that this media company Simulation does great things and is then at, 10 million subs, and we're doing lots of great stuff. And there's some other media company that is also at, 10 million subs, and they view us as a competitor. So how do I make sure that I'm safe when I enter this autonomous vehicle, that I have no control over driving?
Yes. So like autonomous vehicle security is an issue, and I think people do need to spend a good amount of effort on that, because if someone hacks into an autonomous vehicle network, that's way more devastating than any other terrorist attack, for example. So I think definitely people need to take autonomous vehicle safety, security seriously. But I'm sure there's people working on that
Yeah. We need people like you guys at DeepScale to also be like, hey, it's really important, like with your voices as well.
Yeah.
That's why we bring you onto the show. We get you guys to talk about what you're doing and the importance of these things, but then also you talk to all your big guys that you talk to about, hey, the safety and security of these things is important. Like you said, it'd be so much more devastating because you can actually silo out individual attacks onto people.
Yeah, so like even now the technology, well, a lot of cars you can like start them from the internet, for example, and have them like back out of their parking spot. So securing those things now is good practice for the future.
Yeah, we're getting there.
Yeah.
It's crazy because when we were in high school, it's so funny that we didn't know what neural networks were. We didn't know what. We had no idea about the robot and AI age that we were entering. No one in high school was teaching us about AI and robots, and that was 2006 to 2010-ish, but nobody was teaching us about that.
I think AI released, the deep learning took off like in 2012-ish, and just made every algorithm so much better. It's just taking over all the classical algorithms.
And now the question is, if we look back at Roosevelt High School in Sioux Falls, South Dakota, are the kids being taught about AI and robots now? That's the question, because even though we weren't taught that when it wasn't popular, now it is popular. Are the kids learning about it now?
I don't know about if they're learning about it in school, but like I'm sure they see it on the internet. Like if they watch this channel, they probably learn a lot about it.
I hope that they are learning about it in school. I hope schools are teaching AI and robotics. I hope they're teaching biotech and decentralization technologies like blockchain. I really hope so, because you got to get kids prepared for the new era of the tech explosion, because long gone are the people that want to do repetitive service or retail industry jobs. By the time they get there, especially kids that are born like today, wow. Okay, how about we ask you a couple of these quick simulation questions. I actually just learned about this recently from Gianni, who we're going to have on the show in about a month in June. He's one of the major communicators of transitioning like Shell and BP and other oil and gas companies to electrification. So he said that there's 50 electric vehicle companies in China.
Yes, and probably.
And so, they apparently in Shenzhen, they unleashed an electric bus fleet.
Yes,
that was like 15,000 buses or something like that. I was like, wow, that is crazy. That already happened?
Yeah, I think China's definitely taking the lead on electrification and tackling climate change, which is a weird shift, but I'm glad they're doing it, they also have like way worse pollution problems, which is why people care about that a lot more than here, because you like breathe the problem every day, so then you're really motivated to push for these kind of projects.
Okay, so then this question is about globalization. How does the U.S. work with China on figuring out how to best move forward?
On which area?
On everything from autonomous industries to even things like geopolitics and geoeconomics around these topics. How do we move forward? How do you think is best to move forward working together?
I mean, there's already decent amount of collaboration among like private companies. Like there's a lot of Chinese car companies that have labs in Silicon Valley. But on like a bigger government scale, I'm not sure. I think there's a lot of uncertainty with how the governments will get along with each other. So,
does that uncertainty ever kind of like rub you in a way that you're like, maybe we should talk about this and figure it out?
Maybe. I think each country can push along its own progress, and I think there's like all the collaboration between the countries in terms of like technology is already happening. So I'm not sure how much extra value there is to like make an agreement, say we should do these goals. Like that does hold the countries more accountable, but each country needs to be motivated to meet those goals too.
Do you think we're alone in the cosmos?
No.
Do you think advanced civilizations are roaming the cosmos?
Possibly.
You answered no. So what do you think they look like?
Probably either, I'm guessing it'll probably look like Earth like 10 million years ago or something like that.
Oh, so you think it's still back in the evolutionary spectrum, the other ones? Maybe, okay.
Well, it's very likely that it's not at the same spot in the evolutionary spectrum, like either way behind or way ahead.
Yeah.
Yeah.
Do you think we're in a computer simulation?
No.
You think this is base reality?
Yeah.
Okay.
Well, I mean, like, you can't know, so that's just what I chose to accept.
Okay, and 2 more quick questions. What's the deepest emotion you've ever felt?
Define deepest.
Or what's the most profound emotion you've ever felt?
I think I usually just feel like a lot of joy, and I think even though it's like a basic emotion, I think it's a good one.
Look at the smile. It's worth so much. And last question is, what do you think is the most beautiful thing in the world?
Most beautiful thing in the world? Probably just everyone working together and solving problems. Yeah.
Anting, this has been such a pleasure. Thank you for coming on the show.
Thanks, Alan.
This has been such a pleasure. Everyone, thanks so much for tuning in. If you guys had a good time, share the content with other people. Let's get more people talking about autonomous vehicles, perception systems for them, what it means like to either have a camera or LiDAR, and how you crunch in all of that data. Thank you to DeepScale for doing that crunching and figuring it all out. We need more people like you.
Yeah, so we're hiring. So.
DeepScale's hiring, links in the bio. Check it out. In the comments, let us know your thoughts. We would love to feature your comments on Twitter and Instagram, so do comment. Subscribe, join us in the movement. We'd love to have you. And help support us on Patreon. We need to keep this sustainable. We need to grow. We got a lot of goals ahead of us to hit, so we need your help in joining the movement. Thank you very much, everyone, and we'll see you later today with Bernard Gunther. Much love. Peace.